Hi, my name is Charlie Thomas with Campbell-Sevey, and we'll be talking now about fluid coil selection. For fluid coils, there's a few things that you need to keep in mind. You've got obviously a process fluid that you're using to do either your heating or cooling, and then you've got your air side that you're either cooling down or heating up. On the fluid side, we need to know what fluid it is, whether it's water or either of the glycols and what percentage the glycol is, or if it's some other process fluid, we'll need to know some of the thermal properties. On the air side, we'll need to know how much air is blowing through the coil, and obviously whether we're heating or cooling, and what the temperature is. If we're doing cooling, we need to know whether we'll be doing any condensing. So we'll need to know the wet bulb and dry bulb, or humidity ratio, or the relative humidity of the air blowing across the coil. On the fluid side, we can do everything from 3/8 inch tubes to 1/2 inch tubes to 5/8 inch tubes, and we offer many different circuitings from 1/6, 1/4, all the way to quad circuiting to match the fluid pressure drop and fluid velocities that you'll need to do the job. On the finned side, we can offer fin spacing from 4 to the inch all the way to 14 to the inch, and sometimes all the way up to 20 fins to the inch. We offer many different fin corrugations to suit your heat transfer needs. We offer many different fin and tube materials to suit your needs. Sometimes you'll need instead of an aluminum fin, you need to go to a copper fin to maintain a copper-to-copper fin tube bond to make sure you don't have differential expansion issues. Or if you've got some process conditions, some airside conditions that are corrosive, then we can go from an aluminum fin to a stainless fin or a coated fin. Or if you've got carbon steel tubes and you need to go to a carbon steel fin, again, for high temperature applications where where you're concerned about that fin tube bond. When looking at tube diameter, there's many different things that can come into play. If you've got a small coil, we would typically look at smaller diameter tubes, whereas if you've got a much larger coil, maybe 90 inches tall by 20 or 30 feet long, we would typically look at a larger diameter coil. Again, you're looking at fluid velocities and fluid pressure drop, where we'll help make that selection.